Lesson 10.9, this is function analysis like we've been doing, but it's with E in the function. These are level 1s. Number 1 says find all intervals on which the function is decreasing. If there is no such interval, submit an empty answer. So we know that to figure out where a function is increasing or decreasing, that deals with its slope, which means we have to take the first derivative of our regular function. And we see a product rule right here, negative 3x times this E function. And so I'm going to keep the negative 3x first. We have to do product rule. Keep the negative 3x times the derivative of this E. And remember that E is the derivative of itself. So I'm going to have this, but times the derivative of its power, because that's the chain rule. So I'm going to go ahead and have times the derivative of this would be negative 4x. And then times E to the negative 2x squared minus 4 power. Plus, now I would be taking derivative of negative 3x, which is simply negative 3, and then times E to the negative 2x squared minus 4. I don't have to do anything different with that. Now I have to figure out where the critical points are. Where is this equal to 0? So I got to figure out how to simplify this up. Well, first I would multiply your negative 3x times negative 4x to get 12x squared, e to the negative 2x squared minus 4. And I'll just put minus 3e to the negative 2x squared minus 4. See how we could factor out this e part, because they both have the same exponent. So I'm going to take that e to the negative 2x squared minus 4 out. That would leave me with a 12x squared minus 3. Okay, it's easier for me to deal with that and then factor this. I'm going to take out a 3 times, that would be a 4x squared minus 1. And this is a difference of squares, so I could even, here, I'll put my 3 times this e. I'll put 3e to the negative 2x squared minus 4. You could have went on and taken out a 3 here. Maybe would have helped you. And then this factors into a 2x plus 1 times a 2x minus 1. Because that's a difference of squares, where I FOIL, the middle terms would cancel, and then I end up with a negative 1. Okay, so this is all one factor. This is a factor, this is a factor. Let's think about setting this equal to 0. I would divide away the 3, so I would have 0 equaling this whole e thing. If you remember, e is about 2.7-ish. So if I have that function as an exponential graphed, you'll see that it has an asymptote here, a horizontal asymptote, where it's never going to be 0. This is not possible. Also think about exponents. I can never have something to a power get anything to be 0, right? E to the 0 is 1, e to the negative 1 is 1 over e, e to the first is e. There's no way to take an exponent and get a 0 out of that. So that we don't have to worry about at all. Our critical points are going to come from here, which would be negative 1/2, and this would be positive 1/2. Make my sign chart, and then everything from there is the same like what we've been doing. So if I chose positive 1 into here, that would be 2 times 1, that would be positive, and this always is going to be positive. Goes back to this graph, showing me that this is always going to be positive, because even having e to a negative power just flips it and makes it 1 over that. It doesn't make it negative. And so positive, then at 1/2, the multiplicity's odd, so I have opposite signs, and then at negative 1/2, multiplicity's odds, I have opposite signs. So where is it decreasing? Right here in the middle, between negative 1/2 and 1/2. All right, number 2. Only thing different is we have now a quotient rule, and we're trying to figure out where it has a relative maximum. So again, maximums happen where we know slopes are changing from increasing to decreasing, right? Positive to negative slope. So I'm going to have to take the derivative of my function, which is low, times derivative of high, which would simply be a 4, so I'm going to put it in front, minus high times derivative of low. So I know I'm going to have to take the derivative of the power. I'm going to put that next. That would be a negative 6x plus 5 times that e to the negative 3x squared plus 5x. Okay, simplify this a little bit. I'm going to distribute here and get this negative 4x times negative 6x is plus 24x squared. Negative 4x times 5 would be negative 20x. And I'm going to put parentheses around it because that's still a multiplication piece. It's this getting multiplied times my e. All right, I'm setting this equal to 0 and I'm trying to factor. I would go ahead and factor out my e part. And that leaves me with a 4 plus 24x squared minus 20x. Okay, so now I'm trying to work on getting this factored. I see that I could divide everything by a 4, so I'll put that in front. And that would become a 1 plus 6x squared minus 5x, but I'd rather write it in the order of 6x squared minus 5x plus 1. So my goal here is to think, how can I get this to be factored? This is a slide and divide where you take your a times your c. What two numbers multiply to make a positive that add to make a negative? So they both have to be negative. That would be a 2 and a 3, but divide by 6. So that would be an x minus a third times an x minus a half. I don't really care about floating that up. I just want the factors. So that would be an x equals a positive a third, x equals positive a half, and we said that setting this equal to 0, e will never equal 0, so this we don't even have to worry about. So then make your sign chart. A third is bigger, yeah, so I need to do a half. A third. No, a third is smaller. That's what I was going to say, and then I still messed up. Because a half, a cup of something, is going to be more than a third. Oh, goodness. All right, a third, a half. Okay, and then let's try 1. I'm going to do it right here. Right here. 1 minus a third, that would be a positive, and 1 minus a half would be positive, and that's always positive. I'm going to do, or look at the x minus a half, the multiplicity is odd, so it'd switch. At the 1/3, the multiplicity is odd, so it'd switch. And then where does it have a relative maximum? Where does it go from positive to negative? Would be right here at x equals 1/3. So again, same thing we've already done, just figuring out how to algebraically work out problems that have e and taking the derivative of that.